Hello, in this video we'll talk about geometry of linear transformations. And we start with the following definition. A function t from v to w is called a linear transformation between two vector spaces v and w if it preserves both vector addition and scalar multiplication. So if t is applied to the sum of the vectors v1 and v2, we get as a result the sum of the images of those two vectors in the space W. And if t is applied to a product of the vector v1 with a scalar k, then we get the scalar k multiplying the image of the vector v1, which is also in the space W. Next, we will have a very useful theorem which is applying to the Euclidean plane. So a function t from R2 to R2 is a linear transformation if and only if there exists a 2x2 matrix A such that the action of t on the vector v gives us the product of the matrix A and vector v for all vectors v in R2. Then, by the definition, the matrix A is called the standard matrix for the linear transformation T, and its two columns are T applied to 1, 0, which is the first basis vector in R2, and the second column is T applied to 0, 1, which is the second basis vector in R2. Finally, we will look at some examples of linear transformations. And we'll be talking about, first of all, the reflection about the x-axis. So we will illustrate it here with the following diagram. We'll have a vector somewhere here, which after the reflection about the x-axis will be located somewhere here, the image. And then in the second example, we'll be talking about the reflection about the y-axis. So in this case, the vector we will take here will be reflected and giving us the vector somewhere here. And finally, the reflection of vectors in the plane about the line y equals x, which is the bisector of the first quadrant, will result in the following. So vector we have here will be reflected and giving us the image here. Thank you very much for your attention.